Kia ora, welcome. My name is Mark Treadwell and this is the 5th video in the series that supports the resource Learning How the Brain Learns. And in this session I want to be looking at curiosity, creativity and the role they play in learning, but also I want to start off by just picking up a few things from the conversation we had in our last video looking at concepts and concept frameworks and ideas. And in that video we talked about automaticity, the fact that we automate many of the actions that we do in any given day. And researchers suggest that we're probably automating up to 90% of everything we do in our day, if not more. And another word for automaticity is forming habits. So a lot of us as educators who are probably watching this have automated much of their teaching day and don't actually think about it. You automate driving. You can drive through a city on your way home and you get home at the end of the day and you say to yourself, you know, I don't even remember going through that set of traffic lights. I don't even remember passing the shop, because you're in automatic mode. Okay, you've formed a habit as to getting home. Okay, so automaticity is very powerful. Okay, and there's also some funny side effects of automaticity as well. If you live in a house with stairs, a long time ago, you'll have automated climbing the stairs. You don't have to watch your feet and carefully place them on the steps. You just breeze up the steps and straight into the room, whatever it is upstairs that you're going to. Now, if you were to pause at the bottom of the stairs and get distracted by something or someone calls out to you, and turn around and instead of starting on your right foot, you start on your left foot, the astrocytes that have mapped and automated that pattern actually get confused, because you put your left foot on the first step, which doesn't actually count. So your right foot goes on the second step. And that, as far as the astrocytes are concerned, because they can't see outside of their world, they're thinking, well, that's the first step. And so you go up step, 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 and you get to the top, and the astrocytes still think there's one more step. So as you put your foot out to step down on that invisible step, the astrocytes sense the pattern, the concept of walking up those steps, the idea of walking up those particular steps, has actually not worked out as it should. And there could be nothing beneath your foot as far as they're concerned. There could be a hole right through to the centre of the earth. So they panic and they release a powerful stimulant into the synaptic region between the neurons and where the astrocytes sit, and that stimulates the neurons to wake up into a conscious state. So as you go to put down that foot at the top of the stairs there, where there is no stair, what happens is you get this terrible sensation, crikey heck, as that stimulant actually wakes you up very quickly and makes you look down straight away to see whether there's a step there or not. Okay, so when you're passing a car on the motorway or a busy road, and you then look in your rear vision mirror, but someone's knocked your rear vision mirror in the local supermarket or something, and it's not quite pointing the right direction. As you go to move into the lane to your left, there's actually a car still there, but you don't see it until the very last minute, and you get that crikey heck feeling. And once again, because you were driving in an automatic fashion without thinking, the astrocytes have got to wake up the neurons to be consciously aware of how to avoid hitting that car. And that happens in quite a number of situations in your life. When things happen that aren't expected by the astrocytes, the pattern doesn't go as it was predicted to go. Okay? So that's some of the exceptions and how they overcome those exceptions. In the last video we talked about the fact that concepts are equitable, because we've had millennia of practice with that. So we've done concepts of fear, concept of body language, we've got the concept of place, space, time, seasons, warfare, etc., etc. We've been doing concepts for millennia, and we do them really well. Born out of a small body of knowledge, into ideas, more knowledge, more ideas, more knowledge, more ideas, concepts building together to form concept frameworks, to explain our world so it makes sense to us. So we've been doing that for millennia. So everybody can build ideas, concepts and concept frameworks. Everybody can do that equitably. Therefore the resource that we have to be creative is also equitable. Okay? Because one of the key outcomes or the key drivers of creativity is having these good ideas, having these concepts and having this knowledge. But the trick is to introduce knowledge just in time and not lots and lots of knowledge just in case. So one of our dilemmas at the moment is the way we teach a lot of our programs is through thematic approach. Through the thematic approach, we front load lots of knowledge about different stars and planets and how big they are and where they are and what their names are and drawing diagrams and making models of them before we even talk about the implications or the big ideas or the big concepts that sit behind that. Often kids end up knowing a lot about space and astronomy and planets and stars and black holes and quasars and lots of stuff, but they don't know how it all fits together. They've got no concept, for example, of distance. Okay, from distance from one planet to another, or the size of our solar system compared to the size of our galaxy, the size of our galaxy compared to another galaxy, etc. How far away those stars are at night, are some further? A lot of the concepts I never understood. And once again, I can pick a device out of my pocket, and if I want to know the mass of Jupiter, there it is. If I want to know which is the 5th planet in the sequence out from the Sun, I can look it up. We don't need to have kids remember these things. So learners shouldn't be driven with lots of content to start with, but rather starting with a stimulus, a prompt, and working from there. And we'll deal with that more when we come to looking at the learning process. So concepts are important. Creativity is the result of having a pool of this knowledge, ideas, concepts and concept frameworks. The more of those we've got, the more toys we've got to play with to come up with new combinations. So the way in which the brain does that is using brain waves. And so what happens in the brain is that the astrocytes, and once again this is the emerging model, but we think now that the astrocytes actually trigger and generate brain waves to go and look for similar brain waves, ones that they might resonate with. And this is called stochastic resonance. We also think that possibly they may also have interference patterns as well, another way of actually doing that. We're not sure yet whether the astrocytes are telling the neurons to actually stimulate those brain waves or the astrocytes themselves are able to generate. We don't think the astrocytes have that capacity at the moment. So we think it's actually the astrocytes stimulating the neurons to produce those. Okay, because the neurons essentially are electrical instruments, okay, electrical cells so to speak. The astrocytes are more chemically orientated. So we'll see what happens in time to come with that. But those interference patterns and those resonance patterns allow bits of ideas and concepts and knowledge, etc., to link together. And once you have that aha moment, it stimulates the brain to map the pattern that links those pieces together. And the good thing about brainwaves is they travel extraordinarily fast, like 300,000 kilometres per second, the speed of light. And so we can actually come up with fantastically complex new ideas and concepts and concept frameworks almost in an instant. And you've probably all had that moment of, got it! And as you suddenly get a solution to a problem that you may have been thinking about days before, and it's suddenly just come to you. Okay? So creativity is about having time to look out the window, drift off and daydream. So for all of you who were told to stop daydreaming and get on with your work, we're now saying, no, you need to get on with daydreaming so you can get on with your work. So daydreaming is important. And at a recent conference of architects, I spoke to architects and I said, look, what we need is sort of Dr. Seuss type towers. And Dr. Seuss was an author of numbers of books about these bizarre animals and creatures and structures, etc. These towers that kids could climb up and stare out a window and just lose themselves and daydream about things. They need that time. They need that time on their own, and they also need some time to collaborate. So creativity can come on your own space, and sometimes it comes when you actually collaborate with others, drawing on other people's expertise. So the dispositions that we're looking for people to be creative are quite wide and varied. For example, it's recognising whenever there is a change, And that can be a change in the environment, a change in the political scene, a change in the nature of the buildings we're in. It can be a change of any sort, and we're going through huge periods of change at the moment. Wherever there is change, there is always the opportunity for creativity. Always. And I watched a couple of young cellists the other day, and my historical notion of playing a cello was, sedate, I would call it. But these guys took it to a whole new level. Brilliant. 2 cellos, the number 2 cellos, YouTube, very, very cool. That is creativity. It's doing something that no one ever thought of doing before. And they are truly extraordinary players of the cello, both of them. So, change, opportunity. Having time to allow the mind to wander is very important. Having a willingness to take risks, absolutely critical. If you're not willing to fail and consider failure a success, then you're not going to be creative. If I talk to a group of people and ask them, can you draw? Most people say, no, I can't. I just can't draw. Truth is, they're not willing to risk having a failure. Everybody can draw, and every art teacher will tell you this. You talk to an art teacher, say, can everybody draw? And they go, absolutely, anybody can draw, given some confidence. So confidence is really, really important. Okay? The time factor, sometimes it's good to actually confine learners to a particular time frame to come up with the right answer, or come up with a solution to a problem. And sometimes it's good to give them time just to go away and think about it, reflect on it, and then come back. So it's mixing that up. There's no defined moment. But if you look at the video in the text, you'll see there's a wonderful video there for a bank, actually, of all things. It's a series of people who are sitting in a truck and just watching out the window, and suddenly they come up with that new idea. Or in the shower, just doodling in the sort of the mist of the shower, and suddenly going, oh my goodness, yeah, that's it. Or sitting around staring at a fire or a goldfish or out to the ocean. All those things can be good stimulus points for coming up with new ideas. So these are things that are these are dispositions that characterize people who are creative. And everybody, absolutely everybody, can be creative. So I'll leave you with that note, and we'll come back soon with the next video clip. But if you want to go back to the book and have a look at this section there, you can do that. Otherwise, you can just jump to the next video. Okay? Thanks very much.